So far, we've talked a lot about the waterfall model. In this video, we're going to talk about other process models that Pressman considers to be prescriptive, including the incremental model, the prototyping model, the spiral model, and the rational unified process. Before we get to these other models, I want to talk about a figure in Chapter 3 of Pressman where he distinguishes between various kinds of process flow. The first kind of process flow we see is the linear process flow. And immediately when you see this, you should think of the waterfall model. Then there's the iterative process flow, in which there are feedback loops among certain framework activities. Then there's the evolutionary process flow, where you have a complete cycle of activities involved in every release, and there are multiple releases. And finally, you have the parallel process flow, in which you have certain activities occurring in parallel, like communication and planning, for example. Okay, that's Pressman's view of process flow. Our view is going to be a little bit different. First, we're going to completely ignore the iterative process flow, or at least what Pressman calls the iterative process flow. The problem is that a lot of software engineers do talk about iterative development. However, when they say iterative development, they're thinking of the process flow that Pressman calls evolutionary. Therefore, we are going to ignore this second process flow, but we will not ignore iterative development. Instead, we're going to use the terms iterative and evolutionary interchangeably. Furthermore, we're not going to talk about the parallel model in this course, and since that's the only model in Pressman that uses the parallel process flow, we don't need to worry about this either. So this should be good news. The only distinction you'll have to worry about in this course are linear versus iterative, or what Pressman calls evolutionary. Okay, let's talk about some more process models. In the incremental model that you see here, the software is broken up into subsets of functionality, and those subsets are delivered incrementally to the customer. Within each increment, you have what's essentially a mini waterfall. Now, according to Pressman, this model, like the waterfall, still works under the assumption that the requirements are known up front and that the requirements do not change over the course of the project. Now let's talk about something that's involved in nearly every software process and is almost universally considered essential to developing a quality product, and that is software prototyping. When you say the word prototype, most people think of a quickly created demo that gives the customer or client an idea of what the final product will do. So why is this so important? Why do you think that someone would want to see a prototype of a piece of software in the beginning stages of its development? Go ahead and take this opportunity to pause the video and think about how you would answer the question in the second bullet here. What is a software prototype good for? Okay, ready? Probably the biggest reason that developers build prototypes is to check and potentially refine the requirements. If I build a prototype and show it to the customer, I'm going to demonstrate some aspect of the product and then ask them if this is what they had in mind for how the product is supposed to work. It can be very hard for a customer to answer that question without seeing something in front of them and seeing how their requirements have been interpreted by the developer. So the first bullet here is by far the most common reason for building a prototype, to nail down the requirements. But the other reasons are equally important. For example, the interface is something that a customer can respond to and evaluate easily. But the third bullet is a little bit different. If you're trying to nail down the design, you're building a prototype that the developers are going to evaluate. Design is important because typically a prototype does not have a good design. If you build one that does, you might consider evolving that prototype into a usable product. That brings us to the final question on this list. What do you do with a prototype after you build it? And there are basically two options here. The first one is just to throw it away. After all, it is just a demo. And if it was only created so that your customer can evaluate it, you probably didn't design it to be enhanced or modified. On the other hand, if it's a design prototype and it turns out the design is one that you want to keep, it may be feasible to keep it and build on it. So there are two broad categories of prototyping. Rapid prototyping, which is the kind you throw away, that's used to nail down requirements. And evolutionary prototyping, which was constructed with the design in mind so that it can evolve into a bigger system. Pressman also talks about the prototyping model that you see here. Despite the fact that the evolutionary prototype is something you can refine and build on, prototyping is not something that is typically advocated as a process model. But you can see here that the prototyping model as described by Pressman has the evolutionary process flow. And recall that, unlike Pressman, we're going to use the terms iterative and evolutionary interchangeably.